What we're going to do is we're going to look at something that's called a net ionic equation. And what the net ionic equation does is allows us to focus specifically on the ions that are involved during a double displacement reaction. So what we're used to looking at normally is what's called a molecular equation. In our molecular equation, we show the complete chemical formula for all of our reactants and products. Okay, and we don't take into account that when ionic compounds dissolve in water, they exist as individual cations and anions. Rather, what we do is we just list the ionic compounds in both the reactants and products. So we have an example here where I have my sodium phosphate react with my calcium chloride. I'll have some sodium chloride produced, and I'll also produce a calcium phosphate precipitate. In our complete ionic equation, what we do is anything that is aqueous, we separate into the individual ions. So any ionic compound that's aqueous gets separated into their individual ions. This helps to understand and demonstrate that we understand that when ionic compounds dissolve into water, the ions dissociate. The individual cation and anion are hydrated, they're surrounded by water, as we talked about, and they float around. So if we take our original reaction of our sodium phosphate reacting with the calcium chloride, we can take a look at it here, and we can see our sodium phosphate is separated into some sodium ions and some phosphate ions. And now the coefficients in front come about because I have two sodium phosphates that will dissociate. And each sodium phosphate produces 3 sodium ions. So therefore, I will get a total of 6 sodium ions in total. And each sodium phosphate that dissociates gives me 2 phosphate ions, or 1 phosphate ion, sorry. And I have 2 of them that dissociate, so that's why I have 2. Likewise, each calcium chloride gives me 1 calcium ion, 3 calcium chlorides dissociate, so I have 3 calcium ions. And finally, each calcium chloride gives me 2 chloride ions, and I have 3 calcium chlorides that dissociate, so I have 6 chloride ions in total. We will notice that in the products, my calcium phosphate does not separate, and that's because it is a solid. Any solid or liquid found in our reactions do not separate into ions, they stay together. Now, having all of these ions present can be confusing, especially since we can see that some ions are present in both the reactants and the products. So what we do is we often will use what's called a net ionic equation. In a net ionic equation, what we do is we remove the ions that are present in both the reactants and products. These ions are called spectator ions. They're present in the solution, but they don't take place in the reaction. Okay? And so we remove them. So if we go back to our example here, we can remove our spectator ions. So we can see that sodium ions are present in both reactions and products, so we're going to remove them. We can remove our chloride ions because they're present in both the reactants and products. And now what we'll do is we'll rewrite the equation with only the ions that are left and any solid or liquid or gas that is produced. And so we're left with this. So this is what we call our net ionic equation. The beauty of this reaction is it allows us to look specifically at the ions involved in the reaction, have a better idea of what's going on. So let's take a look. So when we do this, actually, before we move on to an example, we have to remember our steps. We want to write our net ionic equation. To write them, first we have to have a balanced molecular chemical equation. And then we will separate into our complete ionic equation, cross out our spectators, and then we'll write out our leftovers. So let's take a look at a few examples. Okay, so let's take a look at a couple of examples. So for the first example, what we're going to do is we're going to have magnesium react with an acid. And so what we would do is we would look at our activity series. We would see magnesium is above hydrogen. So therefore, I know that they will react with the magnesium displacing the hydrogen from the acid to produce a compound and hydrogen gas. So here now I've predicted my products. Now remember, when you do this, you have to ensure to balance. Okay. Now what I would do is anything that is aqueous would get separated into its individual ions. So this is still solid. My hydrochloric acid, because it's aqueous, will dissociate into a hydrogen ion and a chloride ion. Because 2 hydrochloric acids ionize, I'll get 2 hydrogen ions and 2 chloride ions. Now my magnesium chloride stays together, will also dissociate into its 2 ions because it's aqueous, and when one of them dissociates, I get 1 magnesium ion and 2 chloride, and my hydrogen gas stays together because it is a gas. Now what I can do is I can go through and I can see that my chloride ion is present in both sides, so it's a spectator, and I can remove it from the reaction. The last thing I want to do is I want to write out my net ionic equation, so anything that's left over. So I have my solid magnesium reacting with 2 hydrogen ions to produce a magnesium ion and hydrogen gas. Okay, let's take a look at a second example. Okay, so here we have our aluminum nitrate reacting with a sodium carbonate. So again, the first thing we want to do is we want to write out our molecular equation. Then we want to balance. We want to add our states of our products. Okay, and so because we see that we have something that is solid or forms a precipitate, then we know that we will have a net ionic equation. So now our next step is to write out our total ionic equation. So here we have our total ionic equation where we took all of our aqueous compounds and we had them break down into the component ions, recognizing that their ions float around. And then what we can do is we can go through and we can look for spectator ions. So we have nitrate on both sides, and we have sodium ion on both sides. So they're both spectators. So we can remove them, and then all we have to do is write our net ionic equation with what's left. And here would be our net ionic equation once we've removed our spectators.